We are moving past single AI assistants. The new approach is linking multiple agents into virtual teams to tackle massive projects. But scaling up introduces a breaking point. Instead of multiplying their intelligence, a team of agents often collapses into a state of chaotic duplication and conflict. This diagram shows phantom coherence. Agents align perfectly, confirming outputs, but synchronize around an incorrect answer. High agreement, useless work. Then the lambda problem. An agent processes the rulebook only to drop teamwork protocols and execute the task entirely alone. Treating these models as pure, objective calculators breaks down in a massive team setting. The coordination problem requires a different approach entirely. The solution involves abandoning the idea of AI as simple software. We have to treat each agent as a subjective observer. This is the foundation of the observer-dependent theory of everything, or ODTOE, a formalism designed to resolve multi-agent chaos. In this framework, an AI does not produce an objective truth. Its output is dictated by the specific cognitive lens, or observation operator, through which it views the task. To build functional multi-agent systems, we must engineer the specific reality each AI experiences. We dictate exactly how it perceives the environment before it generates a single response. The framework assigns 5 specialized roles: visionary, analyst, builder, validator, and coherencer. Each role functions as a mathematical observation operator, projecting the problem into a specific configuration space. This diagram illustrates the mathematical structure governing their interactions, a toroidal topology. The agents communicate along the surface of this shape. The inner ring houses the fast-moving execution loop, the analyst, builder, and validator. Running along the wide outer circumference is a much slower strategic pulse shared by the visionary and coherencer. This topology forces the agents to maintain separate analytical perspectives. It prevents the team from defaulting into a single, identical viewpoint. To test how deep this cognitive framing goes, researchers ran an A/B experiment. They gave 2 groups of agents the exact same framework core, but changed the natural language of their role prompts. The agents prompted in English gravitated toward operational breadth. They drafted precise interface contracts, built responsibility distribution tables, and scanned the system to detect broken links and formatting bugs. This visualization maps their behavior. The English agents expanded horizontally across practical tasks, while the Russian agents drilled vertically into conceptual abstraction and formulas. When merged, their blind spots become visible. The Russian group missed language non-uniformity. The English group missed mathematical depth. Neither could reach the empty quadrants alone. Because the language choice projects the task into a different coordinate system, the prompt acts as an active observation operator. It configures the agent's cognitive space before the first token is even generated. The challenge is synthesizing these fractured realities into a unified system without losing the unique insights of each language. The solution is a parallel protocol called the Roundtable, built on a bilingual architecture. The system uses English at the core to ensure operational breadth and code execution, while utilizing the team's native language to map out the theoretical depth of the problem. Both groups work simultaneously. Before producing a final output, they are forced through a check-first pipeline. The diverse observers must verify the raw input data and formulas against each other before any text or code is actually generated. Forcing these distinct observers into a collision of perspectives yields massive data compression. In a study of 25 agents, this method compressed a framework by 2.5 times and caught a formula error that 20 analytical agents had failed to detect. Measuring basic team agreement does not accurately reflect the health of the system. 5 agents can perfectly agree on a completely wrong answer. This equation introduces a more rigorous metric, adjusted coherence. It calculates the raw team agreement score, but then multiplies it by the average quality of the individual agents. If the individual quality drops toward 0, the multiplier zeroes out the entire result. A high alignment score is worthless if the agents are not applying relevant experience and focusing strictly on the objective data. Mathematically, coherence requires both strict individual accuracy and collective alignment. Agreement without forced diversity and independent verification is a shared delusion. As multi-agent orchestration becomes a standard for solving complex production tasks, the methods for managing these models must adapt. Prompt engineering has moved past typing instructions into a chat box to get a desired output. It is the active engineering of synthetic cognitive spaces. Like the light passing through this prism, the raw data is identical, but the outcome depends entirely on the lens. The reality experienced by an intelligence is structured by the specific linguistic and operational tools it is assigned. The utility of artificial intelligence lies in our ability to purposely design the subjective reality it observes, forcing multiple distinct perspectives to build a unified truth.